I'm Matt. This is Dave with DSX Tuning. We are starting an informational video series based on a lot of inquiries and questions that we've been having via email, social media. So we wanted to cover a couple big topics. The big one for this video is we'll be doing kind of a basic outline, which will break out into smaller, more informational videos. This will give you a basic outline of the Atlas port controller and the rest of its auxiliary pieces that are included with that. So based on some of the questions and things that we get, we're kind of going to cover topic by topic, starting at where this idea came from and where it started, which is actually the piece sitting behind us now, 2019 ZR1 that Dave had to have his hands on from back in 2018 when they came out.
Yep.
So I'll kind of tee it off to Dave. For this, he can give you kind of an idea of where the idea started and where it's at now.
Well, I mean, the idea started because we bought a car for development in the hopes that somebody would be able to do something with it. And as a result, the first thing I had to do was research how everything worked. And being the first and so far the only production GM vehicle with dual injection, I wanted to know more about how that worked because at the time, port injection on top of DI was a very new topic for people. People were trying to find out ways to do it using different controllers and whatnot. And I thought, well, hell, GM probably did a pretty damn good job. So let's see what they did. And after digging in, I found, okay, they have this engine controller that's suddenly far more capable, but they also have this separate module that is extremely tied in. So I thought, if GM can do this, why can't we on an E92 ECU?
One of the cool parts about the ZR1 is several things were born from it.
Sure.
We're the only people doing flex fuel on the C7 ZR1, which is awesome. So that was the primary reason for its acquisition.
Yeah, that was the big one.
The C7 auxiliary pump kit was originally fitted on that and tested on that. So another huge product there. And then transitioning into now, many years later, the Atlas port controller is definitely our best thing yet. So I think we want to dive kind of briefly on the surface level into its operation, what makes it special, and what's important. And I think we wanted to start with the patch available by
Sure.
HP tuners to kick that off.
Well, I mean, going back, the cornerstone on the ZR1 is the fact that this other module was able to receive pertinent information from the factory ECU. So that's where we had to go. There's multiple facets to a port controller and making it work and making it seamless and making it predictable. And a big part of that is communication. I had an outline of how I wanted to do this based on automating the entire port side based off of data that comes out of the ECU. And traditionally, to get specific data out of the ECU, you have to use what's called a DMR. And this is a request you make to the ECU saying, hey, I want this information at this memory address, give it to me. And then it'll do that. And that's all well and good, but you create a ton of traffic by doing that. Knowing what we know and poking things with a stick, we know that there's this very large dormant CAN section in the factory ECU. And essentially, we just went in and exploited it. So instead of having to ask for information, the ECU gets patched to just tell us things on a regular schedule at an extremely fast rate, faster than any of the factory messages come out of the ECU. So again, instead of having to ask for everything, we're just getting it. We're getting it at 160 hertz, all of the stuff we want. And it's on a secondary CAN bus, so we're not impacting main vehicle traffic or anything. It's a very silent upgrade.
And one of the big advantages to that is that the device is a supported device in the HP Tuners interface.
Absolutely. We have a long-standing good relationship with HP Tuners. We used that to help get the device supported in VCM Scanner so that you can actually log everything that the port controller is doing in HP Tuners. You don't have to try and hook up to a separate device. It's very streamlined and very simple. So not only is that good for the average consumer who maybe doesn't even know what they're doing, but it's also a huge time saver for the seasoned veterans that are trying to do anything.
So if we want to touch on the basic operation of what the device is doing, what the Atlas port controller is doing, how would you summarize that, for the end user that isn't going to be tuning their own port control, that's going to possibly be installing this themselves or having it installed, but this is the equipment they need to take their car to the next level?
The best way to describe this is reactive, automated, supplemental fuel injection. That's pretty wordy, but I think that's the most accurate, detailed description of what this does. So again, going back to the patch, we get a significant amount of pertinent data that otherwise you cannot log in HP tuners, things that maybe people don't necessarily know are there, but we're getting all of that. So we have a constant picture of what the ECU is thinking, what it's doing as far as calculating airflow, calculating fuel flow, everything that it wants to see. We take all of that and we process it through a patented algorithm that, again, I developed in November of 2018, I think, after reading about how the ZR1 worked. We take all of that, we process it, we filter it. We've spent a ton of time just seeing what this stuff looks like. And the end result of that is, as long as your input information is good, meaning good injector data for your direct injectors, good injector data for your port injectors, we can take all of that and make it totally seamless, totally predictable. So whatever you ask for, you get.
So with that said, the ease of installation and the ease of tuning are some really big selling points for the Atlas port controller. As far as what you're seeing here on the table, the controller itself, and this actually has the Camaro mount with it, which there's some nice photos that we have for the installation of it. You can see where it exists, but everything kind of tucks out of the way. From there, there's not a ton of pieces to this thing. There's not a bunch of crazy wires or anything. Kind of the heart of it is, we call this one the port link. Dave can kind of explain to you what it does, and really this is how we're interfacing with the factory ECU.
Yeah, that's the main artery of this thing. So you've got two different connectors on the ECU that you need to access. So sorry, C7 guys, you got to take your fender off. In the main connector for the vehicle, there's two CAN buses, a serial wake-up line, and an ignition line. You need to de-pin those from the factory connector, and we give you new wires to replace them with. And all of these wires match the OEM color. There's one exception to that, and that's the CAN low wire for powertrain expansion, which we put a black stripe on just so it's easier to keep track of. In connector 3, you've got your cam and your crank signal. So you'll replace the OEM wires with the ones we give you. You'll take those OEM wires, and you're going to put those into connectors that we give you. Those connectors plug into these two right here. So now you've got something that's completely reversible. You're not cutting and splicing, which I think is disgusting. You wind up with this single 8-pin GT150 connector, which, again, this is your main artery to the port controller. So this will plug in to this connector on the main harness, and that goes into this MX123, which should look pretty familiar because it's the same connector used on almost every GM ECU for the past 20 years. From there, you've got Bank 1 and Bank 2 injector harnesses,
which are also color-coded on the actual injector sub-harnesses.
Right.
themselves.
Not only color-coded, but they're also keyed, so you can't plug the wrong one in. I think the only way you could really screw that up is if you plugged like cylinder 1's injector into cylinder 7 and put them out of phase.
We'll hope that doesn't happen.
Which isn't a big deal, but it will affect individual cylinder cut.
So the localized skill set for installation is really similar to installing a flex fuel kit. As far as the pinning and depinning, and then the plug and play nature of the rest of the harness.
Yep.
So from there, touching on the equipment, the optional portion of that has been incredibly popular is the closed loop operation provided by the widebands and wideband harness, if you want to touch on that.
Sure. So going back to the main harness, there's a single 3-pin connector, and in here we have ignition 12 volt. That's that switched ignition line that you get from your factory ECU, and then a CAN pair, because these are CAN-based widebands. And the reason we use that is because we can get a ton more data out of the wideband beyond just, well, what's the sensor reading? We can have error reporting. We can monitor the heater in it so we know when we should or should not allow closed loop. Tons of diagnostics, things like that. And again, it all becomes plug and play. So this is the C7 harness for widebands. This is the one where you're going to have to pay attention to bank 1 and bank 2. They're labeled. Just keep them straight. There's an integrated relay with fuses. And again, this is that 3-pin connector that plugs into the other one. So really, the only hardline connection you're going to make for anything is power and ground, which are just on ring terminals. But we opted to use this wideband system, again, just because of the amount of data that we can get. And I think that data is very important to what we're trying to do, because the last thing you want to happen is you're in the middle of a wide open throttle pull at 6,000 RPM and your wideband takes a dump, and now it's sending out bad information. Well, a lot of these budget options that are out there, $200, $300 sensor setups, they've got no way to report an error to some device that's using it. Because we monitor those in real time, we can stop. We can say, hey, something's not right. We need to stop responding to this sensor. And the backup plan is if one sensor goes down, we use the other sensor for everything. If both go down, we immediately stop closed loop. We still allow you to get your fuel, but we stop trying to correct for it because we don't have faith in what we're receiving.
So with that said, obviously the widebands and harnesses, those are an option, but this also has fantastic operation in open loop. You can operate it without widebands.
100%. And my best advice to anybody that's trying to use this, the first thing I say, and I'll say it until I die, is just pretend it doesn't exist, because that's how seamless this thing functions. As long as, going back to what I mentioned earlier, you have good injector data. That is paramount. If you have that, it just works. It does everything it needs to. It calculates what to do properly. And my big suggestion to everybody, do your first wide open throttle pull with the widebands active, just in case your tune sucks. Let them correct, see where you fall, make a correction, and then start disabling them. Tune your car in open loop, get it to where it looks great, you really don't have error, then turn it back on. The widebands should not be there to make up for bad tuning.
So with that said, we briefly touched on the equipment here. The next part, and probably the next most popular question I get, answering the phone, answering emails, is what do I need? And there can either be a really concise list or a pretty big list, depending upon what you're trying to accomplish. But I think one of the things that you've already kind of touched on is, A, we need equipment with good data. So I think that starts, like for the port setup, I think that starts, A, with the DI setup having, I think at this point we're saying we prefer you to have an OE high side fuel system, including OEM LT4 injectors and high side pump. Secondly, moving into the port injectors, our big focus is supporting injector dynamics and OE injectors, if you want to touch on that.
Sure. So in the UI for the Atlas, you can pre-select injectors, and we have 6 options that you can choose from. There's LS3, there's LSA, which is the same as LS9. There's the GM 50-pound, which are from the Escalade, I believe they were in.
Yeah.
And then beyond that, you can choose ID 1050s, ID 1300s, or ID 1700s. The reason that we try to shoehorn you into those is data. Data. That's what matters. And those are instances where the information you're getting is accurate. It's repeatable. It's reliable. Reliable, I think, is a big thing. You can do custom injector data, but we will have no sympathy if you have inconsistencies. So just trust us on this one, because this thing follows all of the same rules as an OEM controller, where, again, you need reliable information that has been calibrated, dialed in, empirically discovered, and is true.
To further touch on equipment, we touched on different components here. What do we need? The first thing we need is an E92 or E92A equipped vehicle.
Correct.
From there, you start with the port controller. The port controller itself comes with all of its plug-and-play harnesses, including the port link, the main harness that couples to the Atlas port controller, and then your injector sub-harnesses. So all that is basically one piece. From there, should you choose to use our mount or not, I definitely suggest it. It puts it in a nice place, free from jumbling up your engine bay. The next piece would be do you want closed loop operation? If so, the dual bank wideband, that's available also on the website, including the AFX3 and then the NTK sensors.
With another option on the way being worked on.
We will touch on the roadmap for what is coming with the Atlas port controller. There are several things that are already in development and functioning that we haven't released yet, and then what's on the horizon for that. So we will touch on that. That will include the additional wideband option for onboard widebands. So once you get past the Atlas, the wideband setup and mount, from there, obviously you'll need a way to install the port injectors to the vehicle, be it a set of plates or an intake that has port rails and bungs for injectors. Our plates, they take a 34 millimeter injector.
That's right.
So here we have a set of IDs. The ultra-low plates, well, I'll let you touch on that, on why it was designed the way that it was, but the ultra-low plates, there is an option with them if you already have a set of IDs that maybe you had from another car or something like that, where you can swap that lower O-ring to get those to fit.
And the reason behind that is on the ultra-low plates, the final thickness of that plate is 16 millimeters. And in order to make everything work, we have to enforce using the 14 millimeter lower O-ring, which was popular on like the LS1 and the LS6. GM switched to a fatter lower O-ring, which is what we use on the stock valve cover plates that we sell. But these ultra-lows, you do need to run those lower 14 millimeters, which if you order your injectors from us, we can send them with them. If you order them from Injector Dynamics or whoever is your vendor for Injector Dynamics, you can order them there. Just it's an important distinction to make because we don't want people to be surprised why they can't shove a big fat O-ring in a really small hole.
Touching on the port plates further. So we have the ultra-lows, which are actually what's on the table here. We have a set of stock valve cover plates that will obviously work with your stock valve covers. That's more catered to the guys sticking with LT4s that aren't going to have hood clearance issues.
Yep.
The ultra-lows, those are more guys that are in the Magnusons and stuff like that. So if you want to touch on that fitment for a minute, we do have a plethora of options that gets you to the point where you can close your factory hood. No problem if you want to touch on that.
Yeah, so the stock valve cover plates are exactly what they are. They're meant for a stock valve cover. They clear everything barely. The caveat is that they will not work with a Magnuson 2650 just because of the overhang of the supercharger over the valve covers. And anybody that's installed one would be familiar with the fact that you're even supposed to cut your factory valve covers. Right. The ultra-lows, taking that into consideration, were designed to not only fit that blower, but also fit with our valve covers that we make, our billet welded baffle valve covers, which if you buy that package, then you're totally good to go. You're not trying to bandsaw a bunch of tabs off of your stock valve covers and move stuff around.
And then for hood clearance with the Magnuson 2650, we also have the Gen 2 supercharger cover. If you are in a situation where you're not able to clear your hood or whatever the case might be, or it's required.
Pretty much, and even then, things get tight. If you've got a C7, I would highly suggest cradle spacers. Just take what you can get where you can get it. But yes, we do have a 2650 lid that is designed to clear both the Camaro and the C7 hoods.
Yeah, not pictured here. Those do come when you purchase them on the website. You can put in your custom color. Yep. Obviously, they're available to be customized.
Powder coating is included with those. If you choose wrinkle black as your option, laser engraving is included. That's for basic text. If you want some huge convoluted thing, we're not going to do that for free, but we'll work with you on it. If you choose any other color, unfortunately, we have to machine it just because the laser doesn't react with the other powder colors. It works phenomenally with wrinkle black, but we do have to machine it, which means we have to design it because it's a very complex 3D surface, and we have to project whatever you want onto this surface, and there is time associated with that. Not to mention there's time running the engraving, too. They take I don't know, I'd say 5 to 9 hours, depending on really how complex you're getting.
We talked on all the hardware. Hey, what do I need? The next thing I wanted to touch on was what's coming up, what's in the future, the Atlas port controller roadmap. I think the first thing, and we've actually already touched on this with a short Facebook video showing the introduction to, hey, we've got boost control on this thing. Do you want to expand on that?
Sure. And it's still very much in the early phases of testing, but we're manufacturing our own mechanical linkage for it. We're using a servo that's actually appropriately rated for the hell that it's going to go through. And we're going to give you just a ton of options for how to control this thing, and it's going to be completely isolated into the Atlas port controller. So just to be very clear, this is not a standalone function that we're going to do. This is not, intended to serve as its own situation. This is very much a subset of the port controller, and the only applications that we're going to support are the factory LT4 blower and the Magnuson 2650.
I guess for now, unless somebody else wants to share data, that's our plan right now. Okay, so
that's the plan right now.
Magnuson. So touching on the boost control portion of it, there's some features when I've explained these to vendors and other people are blown away by how we're going to do this. So I know we've got boost by gear.
Yep.
We'll have boost by ethanol content, boost by front wheel speed.
Correct.
Boost by drive mode, which I think is the most killer one. So like touring, track, etc. You'll be able to have a different.
Your snow.
I didn't even think about snow. So snow is that as
you
pretty
can
cool.
set that to just be a dead pedal for the most part.
So really cool stuff with that. And the price point I think that we're targeting. Yes, you have to have the Atlas port controller to operate it, but I think price point wise, super affordable. I think we're shooting for $500 or $600.
Yeah, of which almost half of that is the cost of the actuator itself.
Yeah. We did mention briefly, hey, we're going to be able to control a fuel pump with this thing.
Sure.
You want to expand on that?
Yeah, so we already do a nice drop-in solution for the Camaros and the CTSVs with a dual pump bucketed system that's all billet, uses 2 TI auto pumps. You can use either the, quote, 525s or the 535s, which is the same pump without a check valve. And that's all factory controlled, works great. We essentially daisy chain a second factory controller in place, but we modify it so as to not crash the CAN bus. That gives you total factory control over the pumps, working with actually another patch with HP tuners, which our shop Camaro is running, that gives you even further control because of a 64 gram per second limit in the ECU. I can talk more about that later. But C7s, everybody's like, well, why can't you do it for the C7? Well, the problem with the C7 is the opening of the tank is too damn small, which is why we developed a bucket that holds 2 brushless pumps, and these things are super skinny, but they fit.
Well, they're also very serious fuel pumps.
Yeah,
I mean these
are some serious fuel pumps. They're pretty expensive because they're brushless. That's awesome, but it also sucks because you need a brushless driver for them, and unfortunately, it'll take 2 of them. So
you have to find some space.
That is a fitment problem in its own, but we'll solve that. We may even just come up with our own brushless controller. We'll see where that goes. But even sending a signal to that is a problem because the ECU does not send out a signal that these things can digest. Long term, we'll have a standalone option that does that. It'll just plug into the factory fuel pump power module. It'll create the signal you need. And again, it'll function just like a Camaro or a CTSV where you just get this seamless stock control. In the meantime, we needed a stopgap, so the Atlas is actually capable of doing exactly that. We're already exposed to all the data we need. We've got everything there. There was an open output, so it can create the signal needed to run these and allow this total factory-style control of 1,500 horsepower worth of fuel.
I know we had touched on it ever so briefly. Any plans for the Atlas port controller to control a similar style pump for Camaro?
Yeah, it's just the hurdle on a Camaro is physical fitment. So in a C7, you have a small opening to the tank, but you have a huge, deep well. I mean, looking at this bucket, that pump comes out to probably about where my finger is. And you have all this dead space above, so you can have a tall pump and it doesn't matter. A Camaro bucket, I mean, from the floor to the top of the hat, you're about like this.
Yeah.
That's a pretty squished system.
Yeah, for sure.
So we may be able to lay them over at an angle or make something crazy fit. That's a bridge we'll cross later.
Last part of this part of the roadmap would be onboard widebands. I know we had talked about that for a bit. If you want to tell people a little bit about what that plan might look like.
Sure. So the Atlas port controller has an onboard wideband controller. It's just the implementation is not done right now because it's like pulling teeth trying to get cal data for wideband sensors from anyone. We tried to implement the NTK sensors directly. NGK, when we contacted them, literally hung up. You can't buy that information anywhere, and it's not something that I am equipped to empirically determine. So that was out. That's, again, we use the AFX boxes from ECM. ECM is who makes everything that GM, Toyota, Ford, the EPA, CARB.
Super robust equipment.
Yeah, that is the best, quote, budget option you can buy.
Right. So the idea behind the onboards was we're interfacing with it with no other devices present, but B, it would technically be a lower cost option when we do
Absolutely, because now you're talking just the cost of 2 sensors and the pigtails that you will pin into this. So what we would give you is the 2 sensors, and then you'll have these wiring harnesses. One side's got the connector for your wideband. The other side has 5 pins, which you will just pin into the connector. And it's super simple. Now, because we're handling all of the processing on board, we're in a unique position. We can now do our own error reporting and error handling and error determination. We can monitor the health of these things, albeit they'll be Bosch sensors, which not everybody's super thrilled about, but
Sure.
we can still do the same thing that these ECM boxes are doing, and we can make those determinations about whether or not the data is robust and whether or not we can actually use it. I think the next question everybody's going to have, though, is, well, when's this available for Global B?
That's a good one. Yeah, that's part, I would say, obviously part of the roadmap.
Sure.
We're working on that. Obviously, we already have Global B Flex Fuel, which is available through select dealers. But any idea timeline-wise, or what do you think?
I wish.
Yeah.
The unfortunate reality is that to do this on Global B, you now have to face CAN FD, which by itself is not necessarily a problem. The main CAN bus is authenticated, which means pretty much most of the data you're going to see on that bus is going to be garbage if you don't have key. There is a secondary CAN FD bus, which I intend to, for lack of a better word, do the same exploit on. The problem is that in disassembling all of these ECUs, the Global B stuff packs CAN data totally different. It's a very, not an impossible hurdle, but it's a different hurdle that is, it's just going to take time as far as finding the data that we're going to grab and send out and what we're going to do. That's all squared away.
So we've covered the patch, which is pretty important, or a very surface level introduction to the patch, the hardware and equipment, what's required, some roadmap stuff. Anything else you want to cover that you think is important? We're going to do a deep dive video series on all of these topics that explains things more in detail, hopefully without boring you to death. But I think as of now, we kind of scratched the surface. We've answered a lot of questions. So the next thing would be is, what do you guys want to hear about? What part of it do you have more questions about, so we can address some of these things as we move into the video series that not only covers this, we'll also cover, we'll cover the bucketed Camaro system. We'll cover this as it becomes available. But a deep dive on widebands, the patch, tuning parameters and things like that, how it operates, and then other equipment that we have on the horizon moving forward. So with that stuff said, I think we're probably ready to wrap it up.
Yeah,
unless you have anything you want to add.
No, I think that sums up everything. I know everybody, going back to boost control, everybody wants to know, well, what about turbo cars? Like, it's coming. We would rather do a few things really, really well as opposed to doing a lot of stuff super half-assed. Because if you're the jack of all trades, you will never be king.
I think that's quite true. That's about the best way you can put it. So with that said, think of your questions. We'll come up with kind of an outline of how we're going to release the videos and what comes first. If there's something you're thinking about or questions that you have about the operation, the products, costs, things like that, everything you see here, aside from the C7 pump, is available on the website. If you need help with packages and things like that, you can email myself or Dave. Dave at DSXtuning.com, Matt at DSXtuning.com.
2 T's.
Yeah, 2 T's. If it's 1 T,
if you type MAT, it's going to come to me, and I'm going to delete it.
And then I feel bad. So otherwise, I think with that, we'll wrap it up. Thanks for watching. I know this might be lengthy by the time it's all edited, but I think it's worth the watch.